Okay, so I'm Philipp Koellinger. I'm associate professor in economics here at the Erasmus University. I have three, I would say, complementary fields of research. One is genoeconomics. So this is at the intersection between molecular genetics and microeconomics. So this is where we're trying to see if and how the genetic predisposition of people influences their economic preferences and behaviors. Then second field of interest is behavioral economics. So there it's primarily so experiments, what we're doing in the laboratory and also in the field. And the third field is entrepreneurship research. And there I'm primarily using field data. So the majority of my work is actually empirical. I also have some theoretical work with a co-author, but there I'm really just playing a minor role. So it's really my co-author who does most of it. And so the stuff I can say, it primarily relates to empirical research as I've seen it in these three fields that I've been active in. I don't have a tight definition, but so I think it's one of these things that you recognize when you see it, right? So and it comes in many different forms. Yeah. Some of them I would say are more benign than others. Mm-hmm. It starts. So I would say, okay, so probably the most severe form of scientific misconduct is if you're actually trying to deceive your audience, okay. Purposefully. Mm-hmm. And this includes things like making up data or manipulating data in a way so that you get the result that you want to convey. And then there are more benign forms where the result basically is still the same, so that basically you're not reporting what's actually true, but you're reporting something that is very unlikely to be true. Mm-hmm. But there are a lot of cases where people are doing that not because they want to deceive the public, but simply because they don't know better. Mm-hmm. And this is the case, for example, for false positives, right? And a classic example is multiple hypothesis testing. So I think, especially in management, there is this really awful culture of basically hunting for significant results, right? So a lot of researchers, they're basically just doing data mining, where they test hundreds, if not thousands, of different model specifications and variables. And then they use a p-value of 5%. And whenever they find such a p-value in their results, they declare that they have found a significant result. Well, that is, of course, not really accurate, because you would need to take into account all the different hypotheses you were testing, right? So let's say that you were testing, 1,000. Well, okay. Here's an example. Let's say you have a data set with 100 different variables. And you do a bivariate correlation matrix between all these 100 variables. So then basically you're testing 99 times 99 hypothesis. So what is this? This is, well, it's almost 10,000, right? Mm-hmm. Okay. So if you use a p-value threshold of 5%, you would expect that just by pure chance, you're going to have around 500 false positives in that correlation matrix, right? So if you just pick one of them and you write a paper about it without controlling for the number of hypotheses you were actually testing, mm-hmm. you're very likely to report a false positive. And the reader is very unlikely to know that you decided to write a paper about something that is just a small subset of a much larger data set, and you were just basically picking the raisins, mm-hmm. and you were not honestly telling the audience the number of independent hypotheses you were really testing. And that is, I think, this is a major problem which is really polluting the results that are published. I think in all social sciences, but I think management is a particularly bad case. So I think there's very little awareness of the multiple hypothesis testing problem. And in general, there's very little awareness of what hypothesis testing really means. So very often you get referee comments, for example. So you send in the paper, an empirical paper, it has some empirical result, and you say, well, let's say the best case scenario is you're being absolutely honest about what you did. Let's say you honestly report, I had 10 variables, I correlated them with each other, I found one that has a p-value of lower than 0.5, and I interpret my results such and such. A typical comment that you get back from a referee is, yeah, but where's your theory? So the referee is basically forcing you, after seeing the results, to come up with a theory that you pretend to test. And that is just really wrong. I mean, this is not the idea of hypothesis testing, right? So either you start with a clear theory and you really go out and you test only this theory, or you do an exploratory approach, what most management researchers are doing, but then you should be bloody honest about it and just say, well, I did data mining, here are the hypotheses I tested, these are the results I found, and here are some possible explanations, but don't pretend that you were actually testing a theory. Okay, so yeah, I think this is, so in terms of actually biased results that are being reported in the literature, I think this is the primary problem in the management literature. I think it's not so much that people are actively trying to deceive, or that they're being dishonest, or that they're manipulating the data sets, or erasing data, or misreporting the p-values or something like that. These things, they exist and they're problematic, but I think compared to the publication bias that results just from statistical ignorance, it's a very minor problem. Yeah, so I've come across some of these examples. Some of them benign, some of them not so benign. So the most recent example was, I'm also associate editor of a journal called Small Business Economics. And recently there were 2 cases of self-plagiarism. So so the situation was that so in the first case, one of my colleagues was reading an article that was published in the journal, and he sent me an email saying that, well, listen, this article that you guys published, it actually looks very similar to articles that the same authors have published elsewhere. And I double-checked, and actually the overlap in language and results was, I think, like 60%. So they basically published the same stuff several times in several journals. So I think this is a classic case of self-plagiarism. And so what I did is basically I alerted the editorial office and the publisher of the journal. And they have an ethical board that looked into this case. So then based on their guidelines, they made a decision. And in this case, they decided, because the publication was already 10 years old, that they would leave it with the personal warning of the author, but don't have any further consequences. Then I had a more recent example of a paper that was submitted to us for publication, where one of the referees pointed out that this was basically identical to something that was recently published in a low-ranked journal. So they were basically, again, trying to publish the same thing twice. And in that case, it was authors from a developing country where, I mean, you're not really sure, whether they're aware of, the ethical conduct of scientific publication or not. But clearly, I mean, in that case, we rejected the publication, and I sent the authors, let's say, a very friendly warning. So actually I wanted to be much harsher, but after double checking with the editorial office, they said, well, still, try to be very polite and don't start a big scandal. So I try to be very friendly and modest in my comments. Yeah, so these are the two cases that I can remember, and then of course, I mean, you quite often come across colleagues that are, without actually knowing it, probably misreporting results, right? So that happens quite often in genetics. I have a lot of debates with co-authors and with colleagues that publish results from so-called candidate gene studies, where they start with a small set of genes that they think are plausible candidates for something. Then they find some correlation, they report it in a paper, and that's it. And very often we have very good doubts about these results, because usually the effect sizes are way too big given the actual truly replicated results. We know that candidate gene studies hardly ever replicate. The sample sizes are way too small to have statistical power to report such effects. And often the candidates are also not plausible, so they're either completely arbitrary, or even worse, they look like that they have been raisin-picked after people actually did data mining. So in all of these cases, I think it's often at the borderline between scientific ignorance and actual scientific misconduct. It's a gray area.
Yeah.
Well, I mean, obviously, when you're working with experimental data, there's always at least the theoretical possibility that you can really invent data. But this is something that I've never seen. I mean, in the lab, when we're collecting data, I've never seen any sort of evidence of anyone trying to manipulate the experiment in any way, or to make up data or something like that. I mean, in principle, it's also possible to delete observations, right? So this is, again, this is something that that you see sometimes, that people drop so-called outliers to get statistically significant results. So I think this is an extremely problematic practice. So actually, one of my friends, so we sort of had this half-joking idea that we should write a program that allows the researcher to specify the result he wants to have, and then the program figures out which observations need to be deleted to come up with that result. And we thought that this program would be a huge hit among management scholars, right? So, but I mean, it's half a joke, but I think there is some truth to it. I mean, I think quite a lot of people, when they work with data that is not publicly accessible, they're tempted to manipulate the results so that they come up with something that meets the usual p-value thresholds. I think that's a real problem. A couple of things you can do about it, of course, make data publicly available, the raw data, and just also by the journals. You should always request robustness checks, right? So the editors and the referees, they should insist on seeing the results before any observations have been dropped or deleted or whatever. It's difficult to say. I mean, it depends how evil the researcher is, right? So I mean, if you start out with a bad intention, of course, I mean, you can basically commit fraud all along the way. I'm not really sure how to answer this. So, I mean, in principle, you would say that the further the actual working task is away from the publication, the earlier it occurred, the more difficult it is to see for the referee or the editor whether something has gone wrong. On the other hand, I think that most researchers, they usually started with very good intentions, so I don't really think that a lot of people commit fraud or do anything wrong when they actually do data collection or analysis. I think things really start to get wrong when they start massaging the results, when they don't find what they were expecting to find, or when they're actually writing up the paper and they're just strategically deciding to not report certain things that they did, or to focus on a particular model specification that works and just not report all the others that didn't work. So I think this is where really things usually go wrong. And the sad thing is that most researchers are not even aware of the fact that, I mean, that this is actually some type of fraud that they're committing. So it's a benign sort of fraud if you're not really being aware of, you know, this multiple testing problem, but it still is not really reporting what is scientifically most likely to be true. Well, I'm an economist, right? So I believe in cost and benefit analysis, right? So I think the likelihood of fraud increases with the publication pressure that people are under. And it decreases with the likelihood of being detected and the severity of the punishment. And I think so. One of the reasons for some of the recent scandals that we had was, first of all, that in the last couple of years this was not really a big topic. So the likelihood of getting caught and being punished seemed very, very low for people. So I think that in the past there's quite a high chance that people were doing it. This may change now that we have a couple of you know, negative examples, and you see how, you know, how deep you can fall if you do such a thing. So I think nowadays a lot of people they're realizing that the danger of getting caught is actually not zero, and the consequences are very severe. So that should help. Yeah. But I mean, the incentives for cheating, I think they're still relatively large, because you have these insanely high publication pressures, right? So you have all these point systems, and yeah, I mean, we're basically researchers, even PhD students nowadays, but especially tenure track faculty members, we're being evaluated like sportsmen with purely quantitative measures, right? And I think this is part of the problem, because, well, I think, so if you actually look at the vitas of a lot of people, so some people that have just, you know, insanely good vitas when it comes to their publications, so vitas that almost look too good to be true, I'm pretty sure that in a lot of cases they are not true. So I'm pretty sure that there is something going wrong. But still, the incentive scheme is such that, you know, usually the universities, the academic sphere, they're really rewarding simply a high number of high impact publications, and this is what they all talk about, you know. And, well, how do you get there? Well, you get there by having truly novel results, and usually in empirical work you don't get there by having null results, right? So that is also, it's part of the problem that the journal, and actually even our culture, how we receive the importance of research, is very much biased, right? So we think, or the editors, they think that only significant results and novel results are actually important. I think this is a complete misunderstanding. It's complete bullshit, actually. I think that a null result is just as important as a positive result. It's just important to know that something is not associated as it is important to know that it is. And I think this publication bias towards significant results in the journals is a huge problem that is also causing people to manipulate the data. Again, it's something that has to do with ignorance. And when you look at the journal missions of some of the top management journals, they even have it in their journal mission that they say, we only publish significant results. So they're basically saying, if you have a null result that basically contradicts something that we previously thought to be true, we're not going to publish it. Full stop. And I think, I mean, this is just purely insane from a scientific point of view. I think this is really wrong. One possible solution, I don't really think that you can do much about these quantitative, you know, incentive schemes that universities have. I don't have a better alternative. But I think one thing we should have in management and economics are journals that publish null results. we should have journals where you can submit your work and you know that it's going to be accepted if it's done well in terms of methods, independent from whether the result is positive or negative. They have that in medicine, and a journal that's called PLOS ONE. It's completely open to all sorts of research, independent from whether the results are significant or not. A lot of null results, methodologically well done null results, are published in that journal. I think overall it publishes almost 1/2 of all the journals in medicine, and has a very high impact factor. I'm pretty sure that if you would do something similar in management or in economics, it would also be a success. And even I would go one step further. I would say that it should be a requirement, something that every PhD student does. It's just a replication study of something that people believe is to be true. Just go out, take a data set, maybe a different data set than the original authors, use exactly the same method, and try to replicate what they found. And then just report the results, whether you found support for the original story or not. There should be journals for that type of work, and I think that would really add to decreasing the publication bias and actually increasing what we know and what we don't know. I think actually a large part of the responsibility is on behalf of those that are publishing scientific research. So there is a lot that can be done and should be done. So I already mentioned, I think we need journals to publish null results. That's a very important point. Maybe it's not going to be possible that that leading field journals are going to change their policy and they're going to say, well, we're also going to publish null results. I think they should, but probably they're not going to do that. So instead, we actually need additional journals that do that. Second, I think anything that increases transparency about data collection, raw data, and how that data was processed actually also helps. So making data publicly available that was used for published research is an important step. Also, I think we need a replication culture. So we need people to look at replication studies as important contributions to scientific progress, and not only. So unfortunately, in management, just as well as in economics, there is this culture that usually you pick like one topic that is novel, and you try to be the first one who will report something on it. And if you end up with a significant result, then voila, you have a pretty good chance of getting into a top journal. Then this becomes the reference. Everybody believes it's true, and nobody actually ever replicates it. Right? Yeah. So, and in that sort of culture, you have a very high incentive of cheating, and a very high chance that what actually gets published in the journals is really not true. So yeah, so we need a replication culture. And this is something that I think needs to be done both at the journal level, but also at the level of the universities. I think it's part of the responsibility of the professors that are teaching, also of the faculty members that are evaluating the work of people. I think methodologically well done replication studies should be valued as totally equivalent and perfectly acceptable scientific contributions. So I think that would help a lot, because I mean, if that would be the case, if you would see a methodologically well done null result as just as important as a positive result, I don't think that people would have that much incentives to cheat anymore. Why would they? The incentive would be just do methodologically good work. Period.